Hello and welcome everyone. My name is Ashish Raj and you are watching Priash Technical. Today we are going to start organic chemistry. So, what is organic chemistry? Organic chemistry is the branch of chemistry that deals with the structure, properties, and reaction of the carbon containing compounds. The organic compounds contain alkyl radical plus functional groups. In 1815, a Swedish scientist named Berzelius proposed a vital force theory. In this theory, he said that the organic compounds cannot be derived from the inorganic compounds. That is, organic compounds cannot be formed from inorganic compound, but in 1828 his student Berzelius student German scientist named F. Euler synthesized first organic compound from inorganic compound, and the organic compound name called urea from ammonium cyanate. First synthesized organic compound in lab. When an ammonium cyanate is an inorganic compound, here I have mentioned that organic compound contains alkyl radical and functional group, whereas in inorganic compound contain acid plus base, whereas inorganic compounds contains acid plus base and organic compound contains alkyl radical plus functional group. Later we will discuss what is functional group and various types of functional group. The formula of ammonium cyanate is NH4CNO. When heated, it's give urea and its formula is NH2CO double bond O NH2. Its chemical name is diamino ketone. Also, in our day-to-day daily life, we see many organic compounds, that is carbohydrates, fats, nucleic acids, proteins, and various types. Even in our body, DNA or RNA present in our body is also an example of organic compound. Further, So we will discuss sources of organic compounds. The source from where do we get organic compounds? That is plants and animals. This is the oldest concept that has Berzelius has introduced and said that in vital force theory that only from plants and animals only organic compounds can be obtained. But when Berzelius' student Ohler in 1828 first synthesized an organic compound called urea from inorganic compound ammonium cyanide. When ammonium cyanide is heated, then urea is obtained, and we know that 10% solution of urea contains pH of 7.2. The value of pH of 10% solution of urea is 7.2. Now we will discuss classification of organic compounds. On the basis of classification, organic compound is categorized into two types, that is acyclic or open chain compound, and the second one is cyclic ring or closed chain compounds. In acyclic or open chain compounds, it is of three types, that is first one is alkane. Its formula is CnH2n plus 2. Second one is alkene. Formula of alkene is CnH2n. Alkane is also called paraffin, and alkene is also called olefin. The third one is alkyne. Its formula is CnH2n minus 2. Now we will discuss cyclic ring or closed chain compounds. Now cyclic or closed chain compounds is classified into two types, that is homogeneous cyclic compound or homogeneous cyclic compound. Second one is heterogeneous cyclic compounds. In homogeneous compounds, it is again divided into two types, that is alicyclic compound, and the second one is aromatic compound. Again, aromatic compound is divided into two types, that is benzoate and second one is non-benzoate. Now let's see one by one example of each of the following compounds that I have presented here, and it is a overview of organic classification of organic compounds on what basis and what types of what basis we have divided on classified on which categories, that is in acyclic or open chain. Classification of organic compound is acyclic open chain, and second one is cyclic or closed chain. Again cyclic closed chain, cyclic chain compound. Cyclic compound categorized into two types, that is homogeneous and heterogeneous. Again homogeneous is divided into two types, alicyclic and aromatic, and aromatic is divided into two types, that is benzoate and non-benzoate compounds. Now let's see the example of each. Here alkane, that is methane. Meth means one carbon. Put in the formula, that is n is equal to 1, we will get CH4. Again formula for example of alkene is ethene. It means 2 carbon and its formula is C2H4. Alkyne, ethine, 2 carbon, it's here that is 2 carbon. We put the number of carbon in place of n and you will get the formula for the given compound name, that is C2H2. Now examples of homogeneous cyclic compound, that is cyclohexane. It's in homogeneous. Benzene, it's in homogeneous cyclic compound. Again on the basis of homogeneous we have divided two categories, that is alicyclic and aromatic compounds. Alicyclic example, that is cyclobutane. Its structure is like that. It's in closed form, that is in cycle form, and it has 4 carbon here. That's the symbol of cyclobutane. Cyclopentane, it's the structure of cyclopentane is like this. Now we will divide aromatic compounds. On the basis of aromatic compounds we have divided benzoate and non-benzoate compound. The example of benzoate compound is benzene, aniline, naphthalene. Non-benzoate example is tropolone. The structure of benzene is like this. Structure of aniline is like, it contains functional group of amine. At the place one hydrogen is removed and in place of hydrogen we put NH2. Tropolene, in the further video we will discuss why tropolene is not in the part of benzene group. Then further we will discuss benzoate and each of the following given compound, that is alkane, alkene, alkyne, homogeneous compound, alicyclic, aromatic. We will discuss in further video functional group, homologous series, and preparation of alkane, alkene, and alkyne, chemical reaction, how lab method, how to test between two compounds, how to write the name reactions of the given compound, how to write the IUPAC name of the given compound, and how to convert one compound to another, how to convert. We will discuss various things in the further video.